This 96 assignment is really useful for statistics, okay? We're going to be doing things with margin of error, probabilities, and converting stuff from a fraction to a percent and vice versa. Going to be super useful here. So let's start with number 4. Complete the table, give it exact answers, and you can use the bar notation to get the bar here. So we have 14 out of 25 as a fraction. How do we write this as a decimal, and how do we write it as a percent? So you can just divide it out either by hand with long division, 25 going into 14, or you can use a calculator. I'm going to use a calculator. 25 divided by 14 divided by 25. Woo! That's going to be 0.56. And it's 0.56 exactly. So that's the decimal representation. And now, what is that percent? The 0.56 is some percent. X percent means X over 100. So to solve for X, to find out what this is as a percent, you multiply by 100. Now we're going to get that 56 is X. So it's 56%. It's 56 out of 100 is the same as 0.56. And remember, another way to say this decimal is just 56 hundredths. If it were like this, it would be 563 thousandths. All right, that's how it all ties together here. So a lot of times in statistics, we'll say we want a 2% margin of error. But in the formula, your formula is not going to want a percent. So in statistics, when it's asking for a 2% margin of error, you're going to have to convert that to 0.02. Or maybe I say we have a 33% probability. Well, what that really means is that the probability when we calculated it was 0.33. You can't write, for example, 0.02%. That's meaningful, but that's something else. So that's another number. They are not equal to each other. But you could, for example, write 0.02% in something else. Maybe you're looking at the concentration of some sort of solution. And that just means that you have 0.02 out of every 100. So maybe 0.2 grams of some substance for every 100 grams of that total substance, or maybe over, something like this. So it's still meaningful. And then as a decimal, you'd add 2 zeros like so. And this would be its decimal value. So you'll see this a lot in like chemistry or something. Let me know if you have more questions about this. Or a lot of times in our class, we'll have margin of errors. Maybe you'll have a 2.5% margin of error. You move the decimal place twice, you can do it like this. You get 2.5% margin of error is 0.025 is what you'll use in our formula. We're gonna see that a lot in probability, which is like unit 3, and then in confidence intervals, unit 7, right? All right, next question I want to look over is converting mixed numbers. It's going to be number 9. Convert 5 8/9 to a percent. Write your answer as a mixed number or a decimal rounded to the nearest hundredth. So remember that 5 8/9, that's 5 plus 8/9. That's what mixed numbers are all about. And we can convert each one of these to a percent, or we could convert it to a decimal first. What is 5 plus 8/9? Let's give it a decimal approximation. It's 5.8 repeating. So how do we convert this to a percent? We go backwards. Okay, right? 5.8 repeating is what out of 100? Well, we multiply both sides by 100. Or just move the decimal place twice, depending on how you want to think about it. So Move the decimal place twice. 588.8 repeating percent. Going to be our answer. Now let's make sure to read our instructions. Rounded to the nearest hundredth. So 588. This is rounded to the nearest tenth. We need one more to get it to the nearest hundredth. Oh, and it wants it rounded. So this is the exact answer, but it wants it rounded to the nearest hundredth. Remember, that's the tenths place, and that's the hundredths place. And we round up because really what we have is 588.88888. We need to round to this guy. So we look at that guy. Because that second thing is an 8, that means we round this hundredth place up. Either way, we're going to get 588.89% is our approximate answer. So we use those squiggly equal signs. And the percent sign is already here in my open math. So you should be able to get it good to go right here. Okay. Remember, this number, 5 8/9, is more than 1. If you have something that is more than 1, the percent will be more than 100%. 1 is 100%. All right, last problem I want to talk about is usually a pretty tricky one. It's an application problem, and it's talking about percentage increase. So let's say that we're looking at the U.S. Weather Bureau, and they have a station in Mauna Loa in Hawaii. And it measures carbon dioxide levels. It's been doing this since 1959. So at that time, in 1959, there were 314 parts per million. 1959, this is a good way of doing application problems. Write down what you know. 1959, there was 314 parts per million. Is usually abbreviated ppm. Carbon dioxide, CO2. I don't remember whether the 2 goes in the bottom or the top. Forgive me if I chose wrong. In 2005, 367 parts per million. Of CO2. You can also underline things. Find the increase in carbon dioxide levels and the percent of increase. Round to the nearest tenth of a percent. So what's the increase? What's the difference between these two numbers for the CO2? We just take the difference. 367 minus 314, you can type that into a calculator, and you're going to get 53 parts per million is the difference. 53 parts per million. Great. So what's the percentage increase? And this is what can be usually pretty tricky. And again, we're going to sort of check our answer before we hit submit. Okay. So percentage increase, remember, is always just the increase divided by the original. And likewise, percentage decrease will be very similar. Okay, so what is our increase? It's 53 divided by the original, in 1959 that is, of 314. So what is this number as a percent? 53 divided by 314 is 0.16879. We'll round a little bit. We eventually need to round a different way, but let's just put more decimal places than we need to start. Again, I'm rounding this 8. I'm rounding it to a 9 because the value after that is big. All right, so we need to convert that to a percent. We're looking at the percentage increase. So to convert it to a percent, you can write out the equation like I've been doing, or just move the decimal place twice. We're going to get about 16.879%. And then how did it want us to round? 1/10 of a percent. So it wants us to round right here. So does the 8 round to an 8 or to a 9? It rounds up because the digit afterwards is big. 16.9% is our percentage increase. And one of the ways that you can check about this is what is 16.9% of 314? 16.9% of is multiplication of 314 is, we rounded, so it's not exact, but it's about 53. That's the increase that we were looking for. That increase is 16.9% of 314. So connect those concepts, check your answer, and get some practice all at the same time. And great, we followed directions and got the answer correct. So that's also going to be a very useful thing in statistics, especially later on in the quarter. We'll be looking at some hypotheses and saying, well, we think that the number of people with a healthy diet has decreased by 10%. What does that decrease of 10% look like? The same concepts. So all of these topics are very useful for us, and that's why we're spending time on them. Let me know if you have any questions, and please ask. As I said in the 95 video, also, if you want a full lecture about all of these, I'm mostly presenting them as quick review. Check out the full lecture video and notes, okay? Bye-bye. Good luck and have fun.